Okay, alright, today we move to case 2. Alright, yesterday we talked about case 1. Case 1 is normal distributed, uh, and mean given, okay, variance given, okay, so that you can calculate the confidence interval for case 1. Right, for case 2, uh, the distribution is not a normal. Okay, not a normal means never mention what kind of distributions. Okay, and the population variance is known. Okay, and the sample size is large. Okay, how large? Okay, n larger equal to 30. So in this situation you can apply the center limit theorem. Okay, so you can do the approximation, okay, to have a normal distribution, means sigma square over n. And if you apply the normal center limit theorem, okay, so your confidence interval, the formula will be same to your confidence limit will be same to, okay, plus minus, okay, z sigma over square root n. Alright, okay, so the basic formula are same, confidence limit. Okay, so once you have the confidence limit, you can start to calculate the confidence interval. Right, so this one will be minus, this one will be plus. Okay, so same things, the cross width will be equal to 2 times z sigma over square root n. Right, okay, so we proceed to example 5. Okay, example 5. The question mentioned the height in cm of men in particular district are distributed with the mean mu and standard deviation of sigma. A random sample of 100 men from the district was taken and the mean height bar was calculated. Okay. The 95% confidence interval for the mu was constructed and found to be between 177.22 179.18. Okay, so this is the boundaries for 95% confidence interval. Right, so part 1. Okay, part 1, they want you to calculate the values of mean and the sigma. Okay, so the question did not give you, they just give you the number of sample. Okay, and they give you the confidence interval, and they give you the uh, percentage, right? And so now they want you to calculate back. Just now this is a backward calculation. Okay, so based on the confidence interval 177.22 and 179.18, right? So you know that this one is a lower boundary, the one is the upper boundary. So you can direct use the I mean the mean minus 95% confidence interval will be, if you use a graph to calculate, you will get 1.96. Okay, center 95%. Alright, so you are going to find p z smaller than z equal to 0.975. So you find back the z will be equal to 1.96. Okay, so sigma square root n, okay, is equal to 177.22, right, the minus part. So another side will be the plus part, right, will be equal to 179.18. Okay, so you have two equation, two unknown. Okay, you may able to solve it. So the n will be equal to 100, right? So 100 square root n will be equal to 10. So you will solve this simultaneous equation. Okay, so you may use 1 plus 2. Okay, 1 plus 2 will be equal to 2x. 2 min, sorry, bar x is equal to 356.4. Okay, and you will get the mean, the sample mean is equal to, right, 2. And if you use two equations, second equation minus the first equation, you will get 2 times 1.96 multiply sigma over 10 is equal to 1.96. Okay, so when you calculate, you should able to get the sigma is equal to 5. Sigma equal to 5, right, for part 1. Part 2, based on this sample, calculate the 80% confidence interval for mu. Okay, so once you have these two values, you can try to calculate the confidence interval. Okay, clear first? So that you have 80%, as you know that Pz smaller than Z will be equal to center 80%, so each side will be 10%, equal to 0.9. Right, so from the table, smaller than 0.9 will be equal to Z will be equal to 1.282. Okay, so once you have this, okay, 80% confidence interval, you can form the confidence limit first. The confidence limit will be equal to 178.2 plus minus 1.282. Okay, multiply 5 over square root 100. Okay, so by expand it, you should able to get equal to 178.2 plus minus 0.641. Okay, so your 80% confidence interval will be between 177.559 and 178.841. Right, so this is a confidence interval, 80% confidence interval. So this part you may simplify to 3 SF, 178 until 179, right? So this is for part 2. Okay, part 3. The question say, what is the probability that the 80% confidence interval does not contain mean? Right, so you know that 80% confidence interval will contain means, so the part that not contain mean will be probability of 80% not contain mean will be equal to 0.2, because 80% contain mean, so the not contain mean will be 0.2. Maybe 20% will be 0.2, the probability. Okay, and part 4. Okay, part 4, find the probability that the 80% confidence interval contains mean, but the 95% confidence interval does not contain mean. Okay, so means, let's see if I draw this diagram. Okay, so let's say this is 80%. Eighty percent contain mean. Okay, where is mean? Mean will be at the center here. Mean. Okay. So now I will using different colors and see. Okay, let's see. Okay, let's say now I want to show the 95%. 95% content. 95% is here. Let's say. Okay, 95%. So if 80% contain mean, 95% must contain mean also, because the mean will be at the center, right? So for part 4, find the probability that 80% contain means but 95% does not contain mean. So the probability of this will be 80 but not 95 will be equal to 0, because not possible, right? Because 80% already have mean in the center, ma. So 95% definitely will be have a mean at the center, ma. So the probability that 80% for confidence intervals contains mean but 95% in confidence interval does not contain mean will be equal to 0, right? So this part 4 will be 0, right? Impossible, right? Okay, so this is for question 5. Okay, now we move to case 3. Case 3, the question say, we examine the case, the note say, the case that are confident for the mean when the population variance is unknown, did not give you any population variance, right? And the sample size is large. Okay, how large? For this case, if they did not give you any distribution, how large normally is n larger equal to, okay, larger equal to the d, right? So if they did not give you means and you do not know the distribution, then if the n must be larger equal to the d, then you can apply the center limit theorem in order to calculate the unbiased estimate of the mean and the variance. Okay, so for this situation, you need to the formula for this confidence limit still the same. Still the same. But this time, if they didn't give you variance or mean, then you need to calculate by using the unbiased estimate of the S. Okay, 1 over n minus 1 sum of x squared minus sum of x squared over n, right? So you need to apply the center limit theorem in order to calculate the unbiased variance. So this formula is given in your formula booklet. If you can remember, just open and have a look. Okay, so now you can, this is the case. So the confidence interval formula same, just you need to calculate the unbiased estimate of variance. Right. Okay, now we proceed to question 6. Right, question 6. Question 6. Give a reason why in carrying out a statistically investigation, a sample larger than a complete population may be used. Why you need to use? Okay, why you need to use sample? Right, so the basic, as I say, the basics answer will be, if you use sample, so maybe you can say less time consuming. Okay, any others? Okay, maybe you can say less resources. Right, so you can have any reasonable answer, right, to use a sample. Okay, the general one, these two. Okay, so part 2. Rose wished to investigate whether the men in her town have a different lifespan for the national average is 71.2. Okay, the benchmark is 71.2. She looked at the government records for the town and takes a random sample of the age of 110 and given who have died recently. Their mean age in the year was 69.3. Okay, this one is found from the random sample. and the unbiased estimate of the population variance was 65.61. So this one already given you the unbiased estimate of variance. Okay, and A, calculate a 90% of confidence interval for the population mean and explain why you understand by this confidence interval. Okay, so I remove the part 1 first. Okay, part 2. So as you know that mean is sample mean is 60, right? And you know that S square is equal to unbiased estimate of variance. So if you want to calculate the confidence limit 90%, so you have 69.3 plus the Z will be 90% center, right? So two side will be 5%. So what are you going to find? 0.955, right? So look at the table 0.95, you will get the Z value 1.645. Okay, so maybe you can take the exact value, direct square root the variance and the n together, right? So then you can get the exact value easy. Okay, and you should get 69.3 plus minus 1.270. So by expand this, you should able to get the confidence interval is equal to 68. Okay, and 70.6. Okay, this is the confidence interval that you get from the sample. Okay, so once you get this, explain what you understand from this. Okay, so this one simple lah. 90 I mean you can say 90% confidence interval. Okay, will include population mean, right? So 95% confidence in the 90% confidence interval will include the population mean. Okay, and part B, state with a reason what conclusion about the lifespan of the man in her towels could draw from this confidence interval. Okay, so what you can say about so for this part you need to compare this confidence intervals that you have found to the benchmark. I mean the 71.2, right? So you can say the national the lifespan 71.2, maybe you can say does not, okay, lie in the confidence interval, but in the exam you don't like CIR, you should write confidence interval. Okay, so what you can say, so you may say the lifespan of rose towel is significantly okay, you can say significantly different from the national average, right? Because your confidence interval does not contain 71.2, so you can say that this is a different, right? Okay, so this is for question 6, right? So later next question we will proceed to question 7, right?